on. We know that an exponential function is in the form of y equals 2 to the, actually I'm going to use variables. Y equals b to the x. Okay? Now, in this situation, I am going to call my b my base, which that is what it is. I am going to call the x the exponent. Makes sense, doesn't it?
Yeah.
Now, I actually think, I can't remember what variables I used in class, so if you're watching this, don't let it throw you that the variables are different than what's on the notes. The position of the variables is what's important, okay? And then you're going to think I'm nuts, and that's okay, because you guys basically do anyway. I used to call the y the answer, but when we put it into log form, that doesn't really make sense. So a couple years ago, a class of mine actually came up with Fred. So we're going to call it Fred.
Okay.
Okay? All right, so a log is used to find the value of a missing exponent. All right, so it is going to look like y equals log base b try that again. Log base b of y equals x. That's the form. Okay, now I use the same exponents here as I did above because this is how they relate to each other. The little subscript number is your base. The y is Fred, and the x over here is that exponent.
Is y always Fred?
Yes. Okay, the variable y is not always Fred, but in that position of a log, it's always Fred. Okay? All right, so I do want to be sure that everybody that reads this notices these are the same. From this, from exponent form to log form, those are the same number. These are the same. From exponent form to log form, those would be the same number. These, oops, okay, why is it not? Okay. These are the same. From exponent form to log form, it's the same number. All right, so let's actually use some numbers and see if we can make sense of that. So we don't need a calculator for this, and actually for those of you watching it, we were displaced from our classes today, so we didn't have access to any calculators, so we'll do all the calculators in class next time. All right, from exponent form to log form. If I have 2 raised to the third equals 8, I can put that into log form. First, let's label them. This is my base. This is my exponent. And this is Fred. So to convert this into log, I am going to do log. Now remember, I put my base first. So I look over here, and this is my base. So I put my 2 down here. You must be sure to make it a small subscript number so we don't get it confused with Fred. Next comes Fred. So I've got Fred here. So the 8 goes as a large normal size number next to it, then equals, and then I look at my exponent, and since we use logs to find exponents, it makes sense that my exponent is the answer of a log. Now does it make sense why we call the 8 Fred instead of answer, because over here it doesn't look like an answer.
Yeah.
Okay. Now we will do some more examples in a second. We've got a couple definitions just to make sure that when you hear them or read them, you know what the base is. So let's go to the next page and do the definitions. All right, so a common log is a log with base 10. So it could be written as, I'm going to change colors here. It could be written log base 10, let's say, of 10,000. Okay. What this means is, I'm sorry, not what this means. This can be written, because it is a common log, as just log of 10,000. So the thing to know here is if there is no base written, it is common log. So base 10. So kind of like when we do the square root of 4, we don't have to put the 2 up there, right? It's understood. If you see log written without a base, it's understood that it's 10. Okay? All right, natural log is a log in base E. Okay, just a made-up problem. This can be rewritten as LN. And I know it's not in the right order, and honestly, I am not sure the history behind this, but I remembered it because L is log, N is natural, so that stands for natural log. So if I had LN4 equals X, this means log in base E. Okay?
You hear me at home?
Okay, so let's make sure as we start doing examples that we do understand what we're talking about when we do a log. So if I have log base 2 of 8 equals 4, nope, 3, I'm going to do 3. What this says is 2 raised to the third gives me 8. Now in the same way, if I did log base 7 of 49 equals X, what that is asking is 7 raised to what exponent would give me 49.
Oh.
And in that situation, X would equal 2. So when we do logs, we're using the base and Fred to find our exponent, or the variable doesn't have to be the exponent. We could do log base 3 of X equals 3. So what this is asking is 3 raised to the third equals what number? Because here is my base, here is my exponent. In this situation, X equals 27. All right, so let's do just a couple examples and then we will move on. In fact, I'm going to go ahead and put all the examples down and then we will talk through them. All right, so here are some examples. We have 2 raised to the 6th equals 64. I strongly recommend you all actually label them first. We have our base, we have our exponent, we have Fred. So to put it in log, I'm going to do log, what's my base? It's a 2. What's Fred?
No.
It's 64.
Okay.
What's the exponent? It's 6. That is how you would write it in log form. Okay, I'm going to do the next one in a different color because they're kind of squished, sorry. 4 is my base. 1.5 is my exponent. 8 is Fred. And yes, let's clarify, as we did in the last class period, Fred is not a mathematical term. You will not see this on the end of course exam. It's just a way for us to communicate about that particular number no matter what position it is in. So my base here is 4, Fred is 8, my exponent is 1.5. Now please notice how it is obviously, the base is obviously a smaller number and lower than Fred. You have to make that distinction or you could get the answer wrong because I can't read it. Okay? Alright, oops, I lost my 5. Okay, for the next one I want you to pause and try it on your own and then turn it back on to see if you get it right. Go ahead and pause now. We're paused.
Oh.
No, we're not. Okay, so there's your answer. I thought I stopped it. Sorry. We actually paused with you. Alright, so natural log, I did the LN because that's how we write natural log. We don't have to do log base E.
Is that still wrong?
I want you, if you ever write log base E, I want you to then change it to LN. Okay, so now we are going to go from log to exponential form. So we're going to start with our first one, log base 6 of 216 equals 3. So I've got my base here. I'm running out of room, guys, sorry. I've got Fred here, and I've got my exponent here. So I'm going to write this as 6, my base, raised to my exponent of 3, equals Fred, 216. Alright, let's look at the next one. Log base 7 of 49 equals 2. Again, I've got my base, I've got Fred, and I've got my exponent. So my base is 7. I am raising it to my exponent of 2 and equals 49. Now I want you to go ahead and look at the bottom one, and I want you to try to do this one on your own. Pause it, and then when you turn it back on, the answer will be there. Okay, so the key here is that you understand it does not matter where the variables are, it does not matter what the numbers are, the process stays the same. So here, since there is nothing written subscript to the log, that means it is base 10, which is where we got that. This is the exponent, so it goes up here. This is Fred, so it goes over here. Alright, this should be enough to get you through your assignment. If you have any questions, email me. Good luck.